Hi there, this is just another video of me solving random recursive problem. Let's begin. Binary tree maximum path sum. So a path in the binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them, and a node can only appear in the sequence at most once. Note that the path does not need to pass to the root. So the path sum of a path is the sum of the node values in the path, right? And given the root, we need to return a maximum path sum of any non-empty path, right? So this is a valid path, right? The six, this is a valid path, right? It doesn't have to go to the root here, right? This it is also a valid path, right? But this is not a valid path, right? Because it has three connections, right? And we can only have at most two, right? So this will not be a valid path here, right? So we need to either we need to go like this, right? Or like this, right? We can have like one node connect to three paths. The maximum is two, right? The edge can only appear once, right? Uh, yeah, the node can only appear in a sequence at most once. Okay, so that is not valid, right? This is also not a valid path. We have like something here, right? It is not valid path because they are not con connected. Right? This is valid, right? So uh the max path, right? The max path sum must be equal to the max, right? Uh, of the max path sum, right? And the sum of the root, right? Node dot val, right? Plus the left sum, right? The left path sum and the right path sum, right path, right? Sum, right? So the sum that we're gonna have, right? Let's say we have another two nodes here, right? So we're gonna have like a max path can be calculated by uh, connecting these three nodes, right? So which is the root and the left gain and the right gain, right? The right path. So this is 35, right? 42 here, and then we can also do this path, right? And then whatever path is largest on the right here, right? We can connect 20 and 7, right? Or 20 and 15, but 20 and 15 is larger than 20 and 7, right? So we can do this path, right? But the sum going to be 35 minus 10 is 25 plus 9 is 34, right? Which is smaller than 42. Okay, so when we calculate the max path sum, we need to sum the root, right? And then the max left again, the max the max sum on the left, and then the max sum on the right, right? If we encounter a negative sum on the subtree, right? We can just ignore it. So we only care about positive value. Okay, so we will return the so the gain, right? If what is our base case? Our base case is when we reach more, right? So if it is the node is null, we can just return 0, right? That's our base case here. Otherwise, we're gonna return the max, right, of the left of the node, right? Node dot val plus the left again, right? And then node dot right, node dot val plus the right again. So this is the post order traversal here, right? Because we need to process the driver first before we process the the root, right? So when we look at the left gain here, if it is negative, right, then we're just gonna ignore it, right? Same for the right gain, right? We need to pick the max between the node plus the left and the node plus the right here, right? We cannot include them both, right? Because the current node is already connected to uh the parent, right? If we connect both of the nodes, we're gonna have a fork this node right here, which is gonna help us tree connection, right? We just think on it. So we always take the maximum gain that we can possibly take, right? Right. So that's how we are 20, the maximum gain between the sum of this and the sum of this, right? 20 plus 15 is larger than 20 plus 7. So we're gonna return the same 35. Right, so let's walk through an example here. So we can start from the root, right? And we need to look at the left first. So here, the node is null, right? So we can return 0 and 0, right? 0 and 0, right? Okay, and then we have to update our max at sum, right? The max at sum can start at negative infinity. Can start at negative infinity, right? So it would be the maximum of the root, right? Plus the left and the right. So that is 9, right? And 9 is larger than negative infinity. We update 9, right? We'll update the max at sum. But what do we return? We need to return the maximum again, right? From a subtree. So we need to return the max, right? Of 9 plus 0 and then 9 plus 0, right? This is the left, this is the right. Because you can return 9. Yeah? Right. So now we finish the left. Now we process the right side, right? So here we process 15. So 15 is also 0 and 0, right? No children, right? So we can uh we have to update our max at sum if we can, right? So 15 here, right? 15 plus 0 plus 0 going to be 15, right? Which is larger than 9, so we update our max at sum here, right? And what do we return? We're returning the maximum again, right? Which is the maximum between 15, right? Plus 0 and 15 plus 0, which is 15 here, right? So we finish the left. Now we process the right 7, same thing. No, so we return 0, right? Our math pattern gonna be 7, right? 7 plus 0 is 7. It's smaller than 15, so we don't do anything. We do keep the math pattern the same. And then what do we return? Right? We return the max between 7 plus 0, which is the left, and then 7 plus 0 on the right, right? So which is 7. Okay. So now we finish the left and the right, right? Now we need to process the root here. Okay. Okay. So we need to update our math asset, right? So the math asset is going to be the sum of these three numbers, the root plus the left plus the right, which is 35 plus 7 is 42, so larger than 15, so update to 42, right? But what do we return here? We're going to return the maximum gain, right, from the subtree. So it's going to be the maximum of 20 plus 15 and then 20 plus 7, right? Which is 20 plus 15, which is 35. Right? So we return 35, right? So we finish the left, finish the right. Right now we process the root here, right? 10, negative 10. So the maximum, right, gonna be the max maximum gonna be 9 minus 10 plus 35, right? Okay, and that's gonna give us 25 just 9, right? Which is 30, 34, right? Which is smaller than 42. So we don't do anything. And then now we are done, right? We are officially done. So this is our algorithm, right? So the max pass sum will be calculated between this only be the sum of the root, the left gain and the right gain, right? But what we return, we're gonna return the maximum gain, right? We don't between the sum between the root and the left subtree and the sum between the root and the sum of the right subtree, right? We cannot include both nodes, both children, because the current node, right, the parent is already connected to a parent, right? Right. If we include both child, they're gonna create an error, right? Invalid path. Okay. So yeah, another thing to pay attention to is that for example, if the left subtree, right, if the subtree is negative, right, and we're just gonna ignore it. So if it is -9, right, then the max pass sum gonna be 0, right, because the left is negative, so we ignore it. Minus 10, right, plus 35. Let's give it 25 here, right? So we only care about positive path, positive gain, in other words. So let's call this up. So we need a max path sum, right? Starting out at negative infinity. And then we can have a method for maximum path sum passing in the root. And then we can return the max path sum at the end. We're taking in a node, right? So if the node is null, base case we can return 0, right? We need to calculate this is reverse, sorry, this is post order traversal, so we need to process the left first, right? The left and the right first before we can process the root, right? So we're gonna calculate the left path sum and then the right path sum, right? And then we need to update our max path sum, right, appropriately, right? And then we need to return, right, the maximum gain, which is the max between the node value plus the left hat sum, right? Or node value plus uh, the right hat sum. Or we can refactor this a little bit, which is the node value plus the maximum of the left or the right. Like this. Right, so when we note the node value, add the maximum uh, of the left hat sum or the right hat sum. Right? So when we return, we can only pick one subject. We cannot pick both. So now create a fork, which is an invalid path. So it is our max gain, right? So for our max path sum, which is gonna be between the max path sum, right, and the sum of the root, which is the node, right, plus the left path sum and the right path sum, right? Right. So the max path sum will only be three variable, right? The root value, node value, right? The sum on the left and the sum on the right. Okay. And then for the left and the right path sum, right, we only care about positive, right? So positive gain. So we're gonna ignore if it is negative, right? By setting the math.max to 0. Okay. So we're gonna look at the path sum here at having in the node left and the path sum thing in the node right. Right. So to recap here, um, we passing the roots, right? And our math path sum starting out at negative infinity. And then if our base case is when the node is null, right? We can return 0, right? And we calculate our left path sum by taking the max between the 0 and the path sum on the left, right? Because if it is negative, we don't care, and we're gonna ignore. We don't care about negative sum. Okay, same for the right. So we process the left and the right first, and then we process the and then we're not gonna process the root, right? The node. So we update our max path sum, right? And it's gonna be between the max path sum and the new max path sum, right? The current sum, which is the node value plus the left sum and the right sum. And then we need to return the max again. So our max again gonna be the node value always, right? Plus the maximum between the left and the right. We cannot include both because that's gonna create a fork, which give us an invalid path because we're gonna have three edge. Because the node here, right, is already have a parent, right? So if we include both left and the right, it's gonna give us an invalid path, right? Right. The path can only go one way because like this node is already connected to a parent, right? So you can only go either left or right, right? One or two. We cannot take both. And we want the largest possible sum, so we return the maximum between the two, right? But for the max path sum, on the other hand, then we need to take the sum of the root, right, and the left and the right, the left sum and the right sum to calculate the max path. And yeah, we had to process every single node, so that is ON. We use recursion, so our stack frame gonna be O of N. So thank you for watching.